Grade 12s, I hope you're doing good, man. Again, welcome back into our lesson video. Um, let's do this revision of this question paper for the day. Okay, let's continue. By the way, today we're going to be looking at a synoptic weather map, which is displayed by figure 2.4. Okay, yes. So let's go and look the synoptic weather map. As you can see, okay, let's analyze it and familiarize ourselves with it. So we have V, which stands for this high pressure H. First of all, we have you can see that this is the interior of South Africa, né? Yes, so the interior of South Africa is there and so on. Okay, the map of South Africa. So in the interior of South Africa, we have high pressure, which is illustrated by letter V. Okay, we also have a cold front that is approaching Cape Town. Okay, that is almost to hit Cape Town. Okay, yes, by the way, I can say it's overhead Cape Town. We also have a low pressure system that is marked X. Okay, yes, I don't want to give you the name of this low pressure system because they might ask us what this low pressure system is. Okay, yes, that's how it goes. So I think you understand the diagram or the this synoptic weather map. Okay, so let's say like this. Okay, let's go straight to our questions. So figure 2.4 shows a synoptic weather map. So 2.4.1, our very first question, says identify high pressure system V. High pressure system V. Okay, what's the name of this high pressure system that is showed by V here? This is Kalahari high or continental high. Okay, let's go and write answers down. So that is Kalahari Kalahari high, or you can say it's continental high, or you can also say it's Kalahari anticyclone. Okay, yes, Kalahari anticyclone. 2.4.2 says, let's go. 2.4.2 says identify the low pressure system at weather station at X. I told you that they might ask us what this low pressure system that is here. Okay, this low pressure system, let's name it. As you can see, this is a coastal low pressure. Okay, yes, this is a coastal low pressure. Let's go and write the answers down. That is coastal low pressure. Okay, that is coastal low pressure. Okay, let's move to 2.4.3. Okay, okay, refer to the high pressure system at V. Okay, so I mean that let's look closer into our high pressure system at V, which is Kalahari high. And questions, that's the very first question says A, give one reason for its existence, why there is presence of the high pressure system there. You know when it is present, you know why, and an end. Okay, yes, so let's give the reason. Okay, yes, so for A you can say, you know, it occurs in winter. Okay, it occurs in winter. There is only one, okay, one one reason that is required there, which is 2 marks. Okay, but I'm going to give you other reasons why it exists. Okay, so we can also say it exists due to the subsiding air. It exists due to the subsiding air. You know, subsiding air causes high pressure. Subsiding subsiding air towards the surface of the earth or of the interior of South Africa. So you can also say it is located in the subtropical high pressure belt. So meaning that in winter, you know that the subtropical high pressure belt move upwards to be dominantly lying on the interior of South Africa, okay, or over the interior of South Africa. So you can say it is located in the subtropical high pressure belt. Okay. Um, Again, you can also say it exists in semi-permanent belt of anticyclone. You know there is anticyclone. We're experiencing anticyclones, so it exists the semi-permanent belt of anticyclone. Okay, and lastly, we can say it is associated with the subsiding between the highly and infrared cells. Okay, yes, so it is associated. You know, in the tropical regions, we have highly cells that are moving, um, in a cyclonic way or in a round way, okay, or in a circular way, okay, around the tropical regions. And we also have feral cells in some tropical regions, okay. So there are also causes high pressure and so on. They contribute in this in the existence of this high pressure system. So we can also say it is associated with the subsiding between the hardly and feral. You can choose any, okay, you can choose any reason that you think you understand better, so that you can apply during your examinations. Okay, yes, so let's go straight to B. Let's go straight to B. Okay, so B is asking us, how does this high pressure system influence weather conditions of the over the interior of South Africa, or over the winter months? Yes, yes, over the winter months. So how does this high pressure system influence weather conditions over the interior during the winter months? So during the winter months, what the weather conditions that in South Africa were experiencing, which are brought by this high pressure system, which is Kalahari high. Okay, so you know I told you it can be dry air. You know, dry air is, you know, that's the subsiding air. Dry air caused by subsiding air. You can choose any. Okay, they said, yeah, you must bring two. Yes, you must bring two. Must apply two. Okay, answers. Which is equals to 4 marks. Try. I'm going to give you several. Okay. Yes, so clear skies, clear skies, clear skies. There are no skies in winter, you know. Stable conditions. Yes, stable conditions. No rainfall, you know. If there are clear skies, no clouds fall, there'll be no rainfall, okay? No rainfall, or you can say little rainfall. Let me say little rainfall. We can also say yeah, possible frost at night. Possible frost at night. You know that cold subsiding air during the night. Cold frost during night, okay, or at night. You can also say little wind. It's windy, okay. It's windy. There's high pressure and so on. Large temperature range. Large temperature. Okay, so any of the two you can apply. You can choose the one that makes suitable understanding into your mind. Okay, let's move to 2.4.4. So 2.4.4 has also A and B, so refer to the low pressure system at water station at X. So let's refer to the coastal low there. Okay, it says we must refer to this coastal low here. Okay, yes. Let's erase that. So let's refer into that coastal low. Let's refer to it. Okay, the very first question says give a reason for the wind direction at X. Why, or let's give a reason for the wind direction at X. Let's give a why the wind direction of this coastal low is like this. Okay, or let's also give the wind direction exactly, like to give it. Okay, you know it is moving in a clockwise direction. Okay, the wind in the coastal low is moving in a clockwise direction. That's a very first answer. um so you can say yes. So a rotates, so a around it rotates clockwise around the coastal low. So also the air moves from the high pressure to the low pressure. So the air moves from the high pressure, which is the interior of South Africa, high pressure to the low pressure. To the low pressure. That's A, by the way. As okay, that is A. So the examiner needed only one um needed only one um justification, okay, but I wrote you two, right? Yes, I wrote you two, so you can choose which is which. You can apply any, but the most relevant one is the air rotates clockwise around the coastal low. Okay, yes. So B, let's move to B. B says explain the high temperature experienced at weather station X. Why there is high temperature now here at X? Mind you, there are back winds, the hot, very hot dry winds that are from this interior of South Africa. Okay, moving eastwards. to the coastal low pressure. And as they are going down, as we are from here, okay, as we are from the interior of South Africa in the continental areas of South Africa, moving to the coastal regions, to this coastal low, the altitude is decreasing, meaning that when it's going down, it hits adiabatically with the lapse rate of 1 degree Celsius. Okay, yes. So it becomes hot, very very hot, until it arrives here. Okay, these back winds in the coastal low. So that is why. That's the main reason why. By the way, yes. So let's go and give reasons. So first of all, air descends down the escarpment. Descends down the escarpment towards the coastal low. Um, they wanted two reasons. Okay, so the descending air hits up adiabatically. So descending air hits up adiabatically. Okay, yes. So as this air moves down the escarpment, as I said to you, there will be a decrease with an altitude. Okay, this air hits up again. Okay, yes. So these are the two. Okay, let's add the last one. So we can say the possibility of back winds will increase the temperature. That's the main. Okay, possibility of back winds will increase the temperature. Okay, temperatures. Okay, yes. So that's how it goes. You can choose any there. Okay, so I think that's the end of our revision. Um, under these pressure systems that are being illustrated in our synoptic weather map. Um, it was a nice lesson, by the way. Please guys, don't forget to subscribe. If you haven't subscribed yet, please subscribe. Just subscribe. Just click the red subscribe button. Please, I appreciate. Thank you so much. See you in the next following video. Cheers.